Case study based question. Raji visited the exhibition with her family. The exhibition had a huge swing which attracted many children. Raji found the swing traced a parabola path given by y is equal to x square. Answer the following questions. The first question is check whether the function f from R to R defined by f of x is equal to x square is injective, surjective, bijective or neither of both. So the first subdivision is f of x is equal to x square and the function is from R to R. So we can see that the domain is all the real numbers and you can see that 1 gets mapped to 1 square. You can see that 1 gets mapped to 1 square. Minus 1 also will get mapped to minus 1 square. Therefore, you can see two elements are getting mapped to the same element. So, f is not 1 to 1. That means f is not a injective function. Injective means one-to-one function. It is not a one-to-one function. Now, what is the codomain of the given function? The codomain is what they have mentioned. They have given that the codomain is all the real numbers. What is the range? You know that f of x is x square. Whenever you square a real number, it becomes positive. So, range is equal to 0 to infinity. So, what do we observe? Range is a proper subset of the codomain. Therefore, the function is not onto. If it is not onto, what is the other way of calling an onto function? Surjective. The function is not a surjective function. The given function f of x is equal to x square when taken from R to R is neither injective nor surjective. It is neither injective nor surjective. That is the first part of the question. Second one is the same function, but they have changed the domain and the codomain as natural numbers to natural numbers. Again, the same thing we have to verify: injective, surjective, bijective. So second one is f of x is equal to x square. The only change is f is defined from natural numbers to natural numbers. We can draw the diagram and see. Now the domain is 1, 2, 3, etc. Codomain is also natural numbers 1, 2, 3, etc. When you square, 1 gets mapped to 1, 2 gets mapped to 4, 3 gets mapped to 9. Therefore f is 1 to 1. Implies f is a injective function. Injective function. Now, when we see the codomain, what is the codomain? Codomain is what they mention, is nothing but all natural numbers. But what is the range? Range will not be all natural numbers. Range will be square of 1 will be 1, square of 2 will be 4, square of 3 will be 9 and so on. So what do we understand from here? Range is a proper subset of codomain. That means the function is not onto, not onto. So it is not surjective. The function is not surjective. So initially, when it was from R to R, it is neither injective nor surjective. When they changed the domain and the codomain to natural numbers, it became injective, but now it is not surjective. So obviously it is not bijective. The third one, they have made another change. They have changed the codomain as 149, etc. So the third subdivision is same function f of x is equal to x square and f is defined from 1, 2, 3, all the natural numbers to 1, 4, 9, etc. Squares of the natural numbers. So obviously it's very easy. This is all natural numbers. This is specific set. Let us call the set as A. 1, 2, 3 and so on. 1, 4, 9, etc. 1 gets mapped to 1 square, 2 gets mapped to 2 square, 3 gets mapped to 3 square. So obviously f is 1 to 1 implies f is injective. F is an injective function. What is the codomain? Codomain, they themselves are given in such a way that it matches with the range. Codomain is 149, etc., which is also the range. Therefore, f is onto. How do we call an onto function? Onto function is also called as a surjective function. F is surjective function. In this case, what happens? The function is both injective and surjective. Therefore, f is a bijective function. So what do we see here? The function can change its behavior depending upon the domain and codomain. In all the three cases, it is the same f of x is equal to x square. But the changes in domain and the codomain, in the first case, make it as neither injective nor surjective. Second case, it is injective but not surjective. Third case, it is both injective and surjective and hence bijective. The last subdivision is f is a function from n to n defined as f of x is equal to x square. I think this looks easy. F of x is equal to x square, natural numbers to natural numbers. They are asking us to find the range. Range is nothing but the squares of the natural numbers. 1, 4, 9, 16, 25 and so on is the range of the required function.